All right, there you go. Thanks, Shank. Awesome. All right. So hey, this is Yash again, engineering manager at Amazon Keyspaces. Today I'd like to talk a little bit about just our commitment to open source. Oop, give me one sec. Sorry, guys. All right. In terms of agenda, I'd like to really touch upon our approach to overall OSS contributions itself. We'll then have Himanshu talk a little bit about our code and infrastructure level OSS contributions. And finally, we'll have Joel talk a little bit about CP50. So how do we contribute to OSS? To be honest, it's still pretty early days for us in terms of open source contributions itself. And I wanted to touch upon our overall thought process in terms of how we approached OSS. We basically took a three-pronged approach. The first one is really showing presence in the community, right? So common misconception that a lot of folks have is contributions into open source are really code contributions. So we really wanted to build on top of this and show our presence through non-code contributions. So this was one aspect. The second is really getting comfortable with the code development process, right? Especially by taking on small and more well-defined initiatives to just get our feet wet and understand how development is done. The third is really not shying away from larger and more complex initiatives, which is expected from AWS. So this is one area that we also wanted to start contributing towards. So what have we contributed to OSS so far? In terms of showing presence, one of the things that we've done is we've taken a more active role in email lists, voting conversations, and whatnot. Most of the team is also on ASF Slack channels. We're trying to contribute and collaborate where possible on that front. We've definitely started attending community over code conferences over the past couple of years, and we want to do the same more often in the future. And we do want to get started with meetups, and this is something that we want to do going forward. In terms of smaller, more well-defined initiatives, Himanshu on our team has kind of led the way on this front, and it's really worked with the community to, one, donate infrastructure for pre-commit testing, which he'll talk about in a bit, and has also made some code contributions on automated repair. In terms of a larger, more complex initiatives, we have Joel who's taken on CP50, which he'll go into full depth in a bit. So really what's next for us? We'd definitely like to continue building on top of our three-pronged approach and making contributions on all three fronts and really find pain points and opportunities in the community so that we can start contributing. Yeah, that's all I had. Thanks, everyone. I'd like to invite Himanshu to kind of talk through some of our code and infrastructure contributions. Thanks, guys.
Hey, thanks, Yash. All right. Yeah, so I'm super excited to talk about some of Amazon Keyspaces contributions to Apache Cassandra so far. So I want to start from like the beginning. So when we started to make contributions to Apache Cassandra, what we realized was it was kind of difficult to make core code contributions because we really lacked the deep familiarity required to kind of make those big changes. But we did want to help. We wanted to get involved with the community. So one approach that we took was we contributed with infrastructure. So we contributed infrastructure to run Cassandra builds. This infrastructure has been running for about 5 years and has helped run Cassandra builds and provide stability. And that way, even though it's not a core code contributions, it helped us get familiar with the community and more importantly, help the community get familiar with us. So that was something that we did. And more recently, we also donated pre-commit testing infrastructure. Just like any other project, when you're submitting a pull request, you're expected to run tests before you actually submit those so that the reviewer can actually verify that this does not introduce any regression. For Cassandra, this process is a bit more complicated. Because Cassandra is a distributed database. So as part of that test, you have to run a lot of distributed tests. And they take a lot of resources, and that requires having like a fleet of resources that you can run builds on. And what we learned was that large companies do have their own infrastructure to test this, but smaller contributors, independent contributors, they may not have this infrastructure. So we tried to help here, and we donated credits to an ASF-owned AWS account. We set up a Jenkins cluster so that folks can run tests in that. We pushed code samples so that they can maintain this code. And that resulted in this website that's publicly available. Cassandra users and developers can actually submit builds. We've run about 200 builds so far in a few months. And if you're interested, we can, in developing and running Cassandra tests, we can connect you and you can run those as well. Another thing that we did very recently was we collaborated with the community to make small code contributions to improving automated repairs. If you're not familiar with automated repairs, it's one of the coolest new features coming up in new versions of Cassandra. And the reason it's needed is that without that feature, customers have to run repair themselves. Either they have to maintain a separate fleet, or they have to run repair on the same fleet, but they have to figure out a way. And with this feature, repair comes out of the box from Cassandra. And that really simplifies the operational burden for running Cassandra. I was very new to this feature and development process, and I actually collaborated with Jaydeep here, who helped me out with the process. And what I learned was the feature was ready, but there were a few guardrails missing that were preventing it from being launched. So one of the guardrails was that while repair is great to run automatically, if you're actually performing a version upgrade of your cluster, that can result in data incompatibility. So you don't want repairs to run during that time. So I introduced code change to actually detect that and stop that from happening. Similarly with disk size, a repair, when you're running it, takes up more disk space. The reason is it needs to create different versions of the data files as it repairs. Therefore, you need to have some threshold of disk space left. And if your disk usage is very high, you don't want to be running repairs. So I added guardrails for that as well. And through this process, one of the things I learned was that community was very helpful. They're very accepting and very open to helping out to contribute. So that was really cool. So these are the contributions so far, but it's still day one, as we say in Amazon. It's very much the beginning, and we're really excited to work with the community and help in whatever way possible, whether it's to infrastructure, documentation, or code. So and now we'll have Joel to talk about some of our future enhancements.
Thanks. All right. Okay, cool. My name is Joel Shepard, and I'm here at Amazon. I'm going to talk to you a little bit today about CEP 50 and Authenticator Negotiation or Authentication Negotiation. I can't get it straight in my own head which one it is, but it boils down to the same thing. Basically, today you can configure Cassandra with a single authenticator. And so if you want to change your authentication method or something like that, it's kind of a major exercise. Cassandra itself doesn't really support a seamless way for introducing a new authenticator, switching the clients over, and then getting rid of the old authenticator. And so that's actually how I sort of backed into this project. Originally, what I was looking at was I've been talking to some folks at Apple about the possibility of using IAM credentials for client applications to authenticate to Cassandra. And there actually is a path forward for that. But again, the problem then is, okay, well, if we create this new authentication method, how are people going to adopt it? And that's where I started looking at negotiation. So, like I said, that's one of the main purposes of implementing negotiation, is simply to allow migrating your installation to a new authenticator. Whoops, sorry. Okay. So the second thing this will enable is having different clients, different applications use different authentication methods. So if people are using SQL Shell to access Cassandra directly and they want to continue using username and password, they can do that, while your services are using something like TLS or some other well, not password-based authentication with your client. You can set up a single Cassandra cluster that will work with both clients and allow them both to negotiate in a way that works for them. And the last thing I'm aiming for is I want to be able to give the clients a choice of ways to authenticate with the node, but leave the node in control of the ultimate decision of how a given client is going to authenticate. So I'm going to walk through a bit of protocol, and some of you might be really familiar with this, and others might not be. But when a client connects to a Cassandra node, there's a handshake that goes on back and forth between the client, and not all clients do all parts of the handshake, but I'm just going to walk through kind of what the full handshake is today. So the first thing a client could do is send an options message, and basically an options message is just a message to the server asking it what connection options it supports. A lot of clients don't actually do this, but they can. If they do, the server responds back with a supported message and lists all the options that it can accept. And these are things like compression, it lists a SQL version. There's a few other things in there that I'm spacing out on now, but so a list of, I think, five or six different standard options that a server will respond back to the client with as accepting. So then the client moves on to startup. And if it wants to specify options for its connection, this is the point where it does it. It takes the options that the server gave it in the previous step, populates its values for those options, and sends a startup message to the server. And now, depending on how the server is configured, if you don't have authentication enabled at all, or if you're using the allow all authenticator, the next thing the server will do is respond back to you with a ready message indicating that it's ready for you to start sending CQL statements to the server. But if you have authentication enabled, once the server receives a startup message, it'll, whoops, did I just do it? No, okay. It'll reply, sorry, I just did something up here. There we go. It'll reply back with the authenticate message to the client. And the authenticate message contains kind of the fully qualified class name of the authenticator that the server is going to use, which is supposed to be a hint to the client about how to authenticate. The reality is, as far as I can tell, nearly all drivers ignore that. The server sends it, and then the driver just goes ahead and authenticates however it wants to authenticate. And I was actually talking to somebody recently who had done some work on the Go driver, and for a time they actually had implemented checking in the Go driver to ensure that it understood the authenticator the server wanted to use, and turned out to cause more problems than it solved by doing that, so they took it out. So if you look at the driver code, even though the server is saying, I want you to use password authentication, the driver is just going to do whatever the driver is configured to do to try to authenticate. So, and what the driver does is it sends back an auth response message, and it includes the credentials it wants to use, whatever form those take, to authenticate with the node. There are a couple of variations of this. For instance, if you're using TLS, mutual TLS to authenticate, it actually doesn't go through these steps at all, but I'm not going to get too sidetracked on that story. So the client responds with his credentials or whatever response it needs to make to the server to authenticate. Typically, it's just a single response, and the client either authenticates or not, but it's possible for the client and the server to go back and forth several times. But if the server is satisfied with the client's credentials, it logs in the client, sends the ready message back to the client, and that's a signal to the client that it can start working against the server. If the server isn't satisfied, it might send a auth challenge message back to the client, again, if it wants to continue the handshake, or it might just send back an error indicating that authentication failed. So that's how authentication works today. With Authenticator negotiation is pretty similar, but there's the difference is now is that the client can tell the server what authenticators it supports, and the server can pick the one that it wants the client to use and respond back to the client. So I'll walk through this a little more quickly. With negotiation, this is going to be a required step for authenticating. The client sends an options message to the server. The server responds back with a supported message, but there's a new option, which is just an authenticator's key. And that indicates to the client that the server can support negotiation. The client replies back with a list of authenticators or authentication methods that it can use against the server. And the server picks the one that it prefers. So, the client doesn't, at least programmatically, know anything about this. The server is configured with a list of authenticators that it supports in the order of its preference. And what it'll do is it'll pick its most preferred authenticator out of the ones that the client has indicated that it can use. So in this case, it's a password authenticator. The server responds back with the authenticate message, and the rest of the handshake goes on as usual. So, talking through it, it's just basically adding an option, a server option, and enabling the client to populate it with the authenticators. It turns out there's a couple tricky details about this, and the first one is that today there's no language that the server or the client and the node agree on to identify authenticators. Like I said, for the most part, the drivers just completely ignore what the server tells it as the authenticator that it wants to use, and they just continue on. But what the server is sending is sending the class name of its authenticator, and which is really kind of meaningless to the driver. And so one of the things that I am working on is there's some time ago there was this concept of authentication mode added to the Cassandra nodes, which is currently being used primarily for metrics. But we're also going to start using that as a kind of a shared key between the client and the node, so that when the node says it is using password authentication, the client knows exactly what that means and can pick the right authenticator to continue the flow with. The second thing which has created a fair amount of work is that today Cassandra assumes there is one and only one authenticator at runtime, and there's actually, if you do some searching for get authenticator through the Cassandra code base, it is used all throughout the code base to drive other kinds of behavior. And so now Cassandra is going to be able to support multiple authenticators, and so driving business logic off this assumption that there's one and only one authenticator isn't going to work anymore. So needing to do a fair amount of refactoring to basically enable that assumption of a single authenticator to be broken. The last thing is that a lot of the authenticators have global state. So the authenticators aren't singletons, but they act like it. And so this creates some challenges during startup and for testing, because generally what you can't do today is instantiate more than one instance of an authenticator. Generally, most of the authenticators will break if you do. And I'm trying to do this, making as few changes as possible to the authenticators themselves. So that's creating some challenges to deal with that global state. I've been working on factoring out that assumption about the single authenticator and getting the basic handshake going. Once the node implementation is done, kind of the next step is to do a reference implementation for the drivers. So I'll probably do it in the Java driver, but there are some changes that most drivers will need to do to use this, which includes they're required to send the options message. They'll need configuration to be able to list the authenticators they use. They're going to need to understand the idea of authentication mode, and so we want to do kind of one implementation that demonstrates how these things should be handled on the driver side, and then hopefully people can pick that up and take it to other drivers. And then the last thing, like I said, I backed into this trying to support IAM-based authentication. So once this is done, I want to get back to the IAM stuff, and I'm hoping this might encourage other people to start exploring other authentication mechanisms like OAuth or what have you. All right, and that was everything I had. And any questions for myself or Yash or Himanshu? Yes, you're the lucky winner.
Basically, in terms of authentication, I was wondering, are there any plans of exposing that through the sidecar? Well, the sidecar has also authenticators, using this concept of the protocol
I have not looked at, so the question is there any, make sure I have the question right, is there any plan to enable authenticator negotiation for the sidecar, or
Yep, basically.
or between the sidecar and
I mean, for between the sidecar and the Cassandra node, that would be with what you presented probably. But having a similar concept on the sidecar that may or may not be useful. I was just thinking, like, expanding on this concept of authenticators will be useful as well for the parts of the project.
Yeah, I haven't looked into the authentication code on the sidecar, but it's a straightforward enough handshake that I think it'd be probably pretty reasonable to implement it. But I'd be happy to work with you or whoever to figure out how to do it.
Awesome.
Yep. Hi.
Are you going to?
I got a mic for you.
So I see you mentioned protocol. Are you going to talk about some new protocol version with this proposal?
Yes.
Okay. So
Yep.
that's V6 then. That's V6. Protocol V6?
Hopefully, yes. If
Okay.
I can get it done on time. The intent though is that the intent is that drivers that don't support negotiation can continue to talk to nodes that do. Right. So the node will be smart enough to see the information that the driver is sending to it, and if the driver is acting like, I mean, if it's not sending a list of authenticators at all, the node will fall back to its current behavior of using, what will be now be sort of the default authenticator to authenticate the client. So I'm trying really hard to avoid putting things into a situation where not only do you have to update Cassandra to a newer major version to get the protocol changed, but now you also have to even continue using that node, you also have to update your driver to the same protocol. So it should be backwards compatible. All right, cool. Thank you very much.